3 over 2. Okay, and we've solved the whole triangle because we have all three sides and all three angles. Okay, what questions do you guys have?
Couldn't you have just used Pythagorean theorem?
You also could use Pythagorean theorem. That's fine too.
Okay.
Okay. Is Amani here? I don't think so. All right, Ruby, will you solve the next triangle for me?
Sure.
Thank you. Oops, I've already messed up. So we are given that we have this 45-degree angle, a 90-degree angle, and that the hypotenuse is 1 unit.
Yes.
And so what can you do?
You can infer that the other angle is 45 degrees.
Yeah, good. And that's because 180 minus the sum of 45 and 90 should give you 45. Okay. What about the sides?
Each of the sides and each of the angles, so I knew what was what when I was solving.
Oh, you labeled them? Is that what you're saying?
Yeah.
So what did you label them?
The far left corner was right, was the 90-degree angle was C.
I heard that the 90-degree angle was C. I didn't hear the other two though.
Or far left rather is A, and then the top one is B.
Okay, so A, C, C. All right, so little a, little b, little c. Okay. Now what?
I noticed that we had only one of the sides, so I just did sine of 90 over 1, and then I did sine of 45 over B to find side B.
Okay, and what'd you get?
Well, that's the tricky part.
So what's the sine of 90 degrees?
That's 1.
Yeah, so you should just get, you end up getting, if you multiply both sides by b, that b is just equal to whatever the sine of 45 is. Right?
Yes, of course.
And then the sine of 45 is what?
7.
Say it again.
I got 0.7.
So it ends up being root 2 over 2. Okay, so, and then this is an isosceles triangle, which means that the sides are equal. We know that because these angles are equal. Okay, so the side across from the angle has to be the same. So then we know that A must also be root 2 over 2. So we have both of these sides as root 2 over 2. Okay, so we kind of fumbled through that. What questions do you guys have about it? Okay, I'm going to assume that means no questions. If there are no questions, or if there are questions and you're just embarrassed to ask, it's okay. We're going to go through this today, and I'm pretty much just going to give you these rules. So for any like 30, 60, 90 triangle, whatever the hypotenuse is, you should be able to multiply the hypotenuse by 1/2 to get this side across from the 30, and multiply by the hypotenuse by root 3 over 2 to get this side across from 60. So that's going to be a rule that we use today. And the same sort of thing happens with the 45, 45, 90 triangle. For whatever the hypotenuse is of the 45, 45, 90, you take that value and multiply it by root 2 over 2, and that will be your side length for your isosceles 45, 45, 90 triangle. Okay, so we'll go through that at the end of today, but for now, I would like you guys to get back out the applications problems we were doing for non-right triangles. I believe I asked you guys to do a few of them, like maybe 2 or 3 of them for classwork yesterday, or last class, but I said that they weren't going to be due yet. So of what you guys have done so far, what questions do you have about it? Okay, if nobody's going to ask any questions, then I'm going to call on somebody to start one of the problems. And we're going to do a few of them together. So Avanish, what's one of the problems that you did do?
Miss Roberts, to be completely honest, my printer didn't start working, so I didn't do any of them. But I can start on number 2 right now.
Okay, that sounds good. So for number 2, how are we going to label the diagram? That's the very first thing.
Yeah, we are. Yeah, we are supposed to label it.
Yes. So it says a short course biathlon meets a short course. I think that there's a typo there. I think it should be just like meet. A short course biathlon meet requires the competitors to run in the direction of 60 degrees west of south to their bikes. So from the start, they're going to go 60 degrees west of south. So where should I put that 60-degree angle?
It's going to be that line that starts from the start.
So which line, the vertical or the horizontal?
The vertical. That's your south.
Okay, yeah. So my south is here, and I'm going 60 degrees west from there, and west is over here, right?
Right.
So this should be 60 degrees. Oh, I think somebody's trying to join in 20 minutes in. Okay, so then it says, so that goes to their bikes, and then they ride 40 degrees east of south to the finish line. So let's see, I have a north, south, east, and west, and I'm going 40 degrees east of south. Okay, so which angle is going to be my 40? This one or this one? The first or the second?
The one that's starting on the south?
Yeah.
No.
Right in here, I should have 40 degrees. Okay, very good. And then it says, so they run in that direction to the finish line, which is situated 20 kilometers. So that means this is 20 kilometers. Due south of the starting point. What is the distance of this course? Oh, I'm sorry. I labeled it wrong. Where should my 20 kilometers be?
It should be a line from the start to finish.
Exactly. Oops. Also, you guys don't have to print out this sheet to do it. You can make the, just look at it and make the drawings and do your work on paper. Okay, so we have a line going from start to finish. They should be directly above one another. I'm gonna just dash it so that we know it's different. And this should be 20 kilometers. Okay, and it's asking what is the distance of this course? What does that mean, Avanish?
It's how far they went, like how far the competitors traveled.
So am I just going from start to finish and asking how long that is, or?
No, so you're starting at the start and you go they run to their bikes and then they bike to the end.
Yeah, so we're looking at the sum of this side and that side. Very good. Okay, so we need to figure out those side lengths. Do you have any ideas of how we're going to do this?
So we have angle, side, so we can use the sine rule to find the other.
Do we have angle side?
Yeah.
So if
wait, no.
Got my triangle. Okay, without like all the other stuff. We know that this is 60. What else? And this is 20. What else do we know?
We know the outside angle is 40 degrees.
This?
Or the
We know this little guy's 40 degrees, but we don't know this guy yet, right?
right.
Okay, so how are we going to figure that out? And I'll let anybody join in at this point. Does anybody have any ideas for figuring out what this angle would be?
I did it.
Okay, what do you think?
So since, like, if you look at the 60-degree angle between south and west on the start point,
Yes.
the other angle on the outside to fill into west would be 30 degrees
Okay, yeah, why?
because they're supplementary.
Yeah, very good.
And what happens is they're like opposite interior angles, I believe. So if you look at the second point, half of that angle is going to be 30. And then,
Well, not half, right?
well, yeah, not exactly half, but one part of it is 30.
Uh-huh.
And then you can look at the 40-degree angle and see what is supplementary to that, which would be 50. And then you can add 50 and 30 and find out that that angle altogether is 80 degrees.
Very good. So this should be
I think
80.
you complementary angles, but
Yes,
it's the
I was thinking the same thing.
Oh, yeah. I just
Step
picked
two.
the definition and stuck with it.
Yes, so complementary angles. So we got this 30 degrees from 60 and 30 being complementary. And then because west, the little compass lines are indeed parallel, we can use alternate interior angles here with this line being our transversal. And we can choose this to be our 30-degree angle. Very good. You also could have like drawn across and said, oh, this is a 90-degree angle right here. That's a 60, a 90, and then force that to be 30. That would also work. Okay. Okay, and then what else can we figure out? So once we have that, can we figure out any of the other sides or angles?
We can figure out
we
the
can
last
get the
angle.
third.
Oh
We
yeah.
can figure out the last what?
I said the last angle.
Yeah, what is it?
So it's 80 plus 60 is 140 minus 180 is 40
Okay.
degrees.
Good, so we get a 40-degree angle there. Okay, what else? So let's call this X and let's call this Y so that we have some names here. Okay, and our goal is to find the D, the total distance, which is going to end up being X plus Y. So that's our goal. So what can we use to figure out what X and Y are?
Oh, we can use the sine rule.
Good. So can you tell me one of the equations we could set up for the sine rule?
Yeah, so we could do, well, if we like label 80 as A, 60 as B, and 40 as C, we can do,
Let's
well-
not do that. Let's just use like the measure.
yeah, okay.
So,
So we could do, hold on. So
we
if we
need
look,
like X or Y in there, right? So which one do you want
Yeah.
to do?
we'll do X.
Okay, so X, and what angle is across from X?
40.
Yeah, so the
So we
sine
have
of 40.
sine of 40. And then we could multiply that by 20
Right.
over the sine of 80.
That equal to, but yes. Good. And then what should we get for X?
Hold on, let me calculate that. So we would get 20 times sine 40 equals X times sine 80. So then we divide both sides by sine 80, and we would get 13. It would just round to 13.1.
Very good. And we're doing 3 sig figs, so 13.1 kilometers. Very good. Thank you. Good job, Keith. Okay, and then I need one more person to set